Welcome back, everyone. I am so thrilled you're here because honestly, we have a genuinely mind-bending topic to unpack today. In this explainer, we're diving into some fascinating new research by En-Ho Chen and Yulin Shah, a paper submitted to arXiv in April 2026 called AI Tool Discovery at Scale. All you need is DNS. And what they're proposing here is absolutely a paradigm shift. They're basically saying that to solve one of the biggest, most cutting-edge bottlenecks in autonomous AI right now, we don't actually need to invent some wildly complex new framework. Instead, we just need to leverage the rock-solid, decades-old technology from 1983 that already runs the entire internet. You know it, you love it, the Domain Name System, or DNS. 33,688. Now, that is not just a random statistic. It actually represents the exact number of real-world tools that the researchers evaluated in their benchmark dataset. We are talking about tens of thousands of different capabilities that an AI agent might need to grab at any given millisecond, and they span across a whole bunch of different protocols and standards. Which brings us right to the core question of today's explainer. How exactly do autonomous agents find the right tool in milliseconds? I mean, as we enter this era where AI agents aren't just, chatting with us, but actively taking actions, they desperately need a discovery mechanism that can navigate not just thousands, but millions of tools. And they have to do it instantly, without totally crushing our internet infrastructure. So here is our roadmap for today. We'll hit 1. The AI tool bottleneck. 2. The ToolDNS paradigm shift. 3. How ToolDNS actually works. 4. Benchmarks and real-world results. And finally, 5. Preparing for DNS-native agents. Let's just jump right in. Section 1. The AI tool bottleneck. Fragmented protocols. So why exactly is the current way AI agents discover tools hitting such a massive wall? Well, right now, the AI tooling landscape is just incredibly fragmented. Agents are basically forced to route across completely incompatible discovery standards. We've got the Model Context Protocol, or MCP. We have agent-to-agent communication protocols, your standard RESTful APIs, and a bunch of various skill protocols. Building autonomous agents that can seamlessly talk across all these boundaries, it is an absolute routing nightmare for developers. Just to visualize this bloat for a second, take a look at a tiny snapshot from the GitHub MCP registry. It's a cataloging nightmare. You've got Microsoft's Markdown for converting files, NetData handling real-time infrastructure monitoring, official integrations for Notion, and Playwright for automating web browsers. The sheer variety is amazing, sure, but it creates a massive, massive indexing problem. So the crucial takeaway here is this. The current solution, centralized semantic search using heavy vector databases, scales incredibly poorly. As these tool inventories explode into the millions, the search complexity approaches what computer scientists call O of N complexity, which basically means the time it takes to find a tool grows linearly with the number of tools that exist. To put that into perspective, it's kind of like forcing an AI to read a giant phone book from A to Z every single time it wants to take an action, instead of just using a search bar. This creates severe latency bottlenecks, massive single points of failure, and major friction for multi-tenant deployments. All right, moving to Section 2. The ToolDNS paradigm shift, a counterintuitive fix. Here is the definitive, absolutely brilliant solution proposed in this research. We are talking about a complete shift from heavy, centralized database queries to lightning-fast, decentralized infrastructure. Look at the comparison. On one side, current HTTP-based registries require centralized governance, they suffer from that brutal O of N complexity, and they demand compute-heavy vector matching that pushes latency way up into the 200 to 800 millisecond range. But ToolDNS, it retrofits semantic tool discovery directly onto the domain name system. It uses UDP-native hierarchical routing, which completely drops search complexity down to O of log n, which is exponentially faster. It's incredibly network efficient, and the latency literally plummets to just 10 to 50 milliseconds. Section 3. How ToolDNS actually works. Retrofitting DNS. So you're probably wondering, how is this wizardry actually possible? Let's look under the hood at how they retrofitted semantic tool discovery onto DNS without, breaking the internet. It all hinges on a very specific internet standard, defined in RFC 6891, known as eDNS0. So decades ago, traditional DNS messages over UDP were strictly limited to 512 bytes. eDNS, which stands for Extension Mechanisms for DNS, expanded that limit. But actually, the most important part for us is that it allows requesters to send structured metadata using what's called an opt pseudo resource record.
Think of it like slipping a specialized, highly detailed instructional note into a standard shipping envelope. It lets agents attach semantic search intent directly into the DNS query without confusing any of the legacy routers that rely on fundamental DNS headers.
The whole architecture relies on 3 protocol compliance steps. First up, partially unfolded names. Instead of flat strings, tool identifiers are structured as hierarchical domain labels. This is huge because it means DNS resolvers can instantly prune irrelevant branches of the search tree right out of the gate, entirely avoiding full tree scans. Second, they leverage those eDNS0 intent payloads we just talked about. Agents attach semantic query parameters directly into the eDNS0 buffer, and then the authoritative servers parse these to filter results before returning the endpoint record. And third, logical subdomains. Semantic categories and trust boundaries are mapped to subdomain levels, so a query resolves through a hard, deterministic path rather than some fuzzy, similarity-based ranking. Put these 3 steps together, and you successfully convert an expensive, compute-heavy vector lookup into a super lightweight O-log-N name resolution. No vector database lookup, 0 pagination, and absolutely no secondary HTTP fetches.
Which brings us to Section 4, Benchmarks and Real-World Results, Evaluating Tools. Theory is great and all, but how did ToolDNS actually perform when they put it up against that massive dataset of 33,688 tools? 95.26%. That is a staggering number. By using that hierarchical pruning to eliminate irrelevant tool candidates before a single network round trip even occurs, ToolDNS slashes the per-query search space by over 95% compared to baseline semantic registries. And because of that massive reduction in search space, the latency just drops off a cliff. Traditional multi-step HTTP fetches can take up to 800 milliseconds, right? Because of authentication, payload parsing, database joins, the whole shebang. But ToolDNS, querying against UDP-native Anycast servers, drops that to a mere 50 milliseconds. That is literally orders of magnitude faster. When you have an autonomous agent chaining together dozens of tools to complete one complex task, shaving off 750 milliseconds per tool discovery is an absolute game changer.
Now, I know what you might be thinking. Okay, sure, it's fast, but what's the catch? Does it actually find the right tool? The answer is a resounding yes. The benchmarks absolutely confirm that this massive boost in speed doesn't cost you anything in retrieval accuracy. Because the semantic intent is perfectly preserved through that eDNS0 payload encoding, the precision doesn't degrade during the DNS translation step at all. ToolDNS matches state-of-the-art vector-based retrieval accuracy. It just trades compute-heavy matching for incredibly network-efficient hierarchical routing. Okay, let's wrap up with Section 5, Preparing for DNS-native Agents. Prepare for the future. What does this actually mean for you? What should developers, infrastructure architects, and framework maintainers be doing today while this research matures? So, even though ToolDNS is technically a research framework right now without production-ready client SDKs, you should absolutely treat this as a strong architectural signal. Here are the actionable steps you can take today. First, keep an eye on the archive repository for early client libraries that implement this eDNS0 intent parsing. Second, evaluate your current orchestrator routing. Really document your latency and compute costs for those HTTP-based semantic registries, because those are the exact metrics ToolDNS is coming for. Third, start preparing for DNS-native endpoints. We can expect early adopters to start publishing tool endpoints as SRV or CNAME records alongside their traditional HTTP APIs, so make sure your client libraries can gracefully fall back to DNS resolution. And finally, start testing your client-side caching behavior. If you're going to experiment with DNS-based routing, you will definitely need to configure conservative time to live or TTL limits so you don't end up with stale routing tables. I want to leave you with this really powerful quote directly from the paper. Scalable AI interoperability does not require building more middleware. It requires routing existing infrastructure more efficiently. Instead of piling on more fragile overlay networks and complex databases, maybe the true key to scaling AI is just learning to speak the language the internet already understands. So what do you think? Are you ready to rip out your vector databases and let the internet do the routing for you? Definitely something to chew on as you build out your next agentic workflow. Thanks so much for joining me for this explainer, and as always, keep building efficiently.